Hello, this is Mr. Rasmussen and welcome to Algebra 2, Lesson 82. This lesson starts off with reminding us about the three most basic operations that we can do inside of algebra to be able to simplify and reduce an equation. First of all, we can add the same quantity to both sides of the equation without changing it. Secondly, we can multiply the same thing to both sides except for 0, and it doesn't change the equation. And then thirdly, the numerator and denominator of an algebraic expression can be multiplied by the same quantity, once again except for 0, and it doesn't change the expression. And so therefore we use the variations of those three to be able to solve things. And so today is just a further deepening into using the algebra rules that you already know about. So we have, I'm going to suggest you look at the examples in the lesson and work through those a little bit, and then pause the video and work through the practice problem, then watch and you can compare your work and the answer to mine and see if you've got it. So first of all, we are going to simplify this expression right here, and really all it is an onion where we've got layers upon layers of doing the exact same thing. A lot of numerator denominator rule. So we're going to start at the bottom with the innermost layer, and we're going to add these two terms together. Our common denominator is going to be a, and so since this one doesn't have it and it's going to be added, that's going to be rewritten as 3a plus 3 over a as a simplification of just this first part. Okay? Then what that looks like is I'm going to rewrite that, we have x over 1. Okay, if we put this into a fraction, x over 1 here, and then the 3 is sitting out in front there, and I didn't write the 1 in. So we add these first two terms. There it is. Our next step is this fraction here to get that into one fraction. So we do that by inverting. If I invert such as this, okay, everything's going to cancel, and what I do to the bottom, I also have to do the top, so it looks like that. And so these are all multiplications. So now I'm going to rewrite it down here, 3 plus xa over top of 3a plus 3. And then obviously I'll do it in a different color, but our 1 is still sitting up in front there at the top. Okay, so next we're going to deal with now these two terms. Okay, we want to get those to be the same. We're kind of back to where we started. We've got two terms, and this one is over top of understood 1. So what is my common denominator? My common denominator is going to be this guy here. So I'll move over here to the side. Back up here. My common denominator is going to be 3a plus 3. This doesn't have anything on the bottom, so as I add it on the bottom, I also have to add on the top. So that's going to look 3 parentheses 3a plus 3, and then plus this one already has the whole denominator, and so I write it out like that. Let's remove the parentheses and rewrite it. So I'm going to get 9a plus 9 plus xa over top of 3a plus 3. Now, we still have this other part here. I'm writing that in red. If we were to write that, they're a larger fraction we're still dealing with. If we were to write that as a fraction, it'd actually be 1 over 1, right? And so to get these two smaller fractions, one fraction inside the denominator, one inside the numerator, to be only 1, then once again, I'm going to invert and multiply. So as I invert, basically, the 3a plus 3 is on the top, and the 9a plus 9 plus xa is on the bottom. And so basically, if I were to write it up here, this part's going up top here, this part's going down here. In the bottom, everything cancels, but on the top, okay, if I multiply it by 1, nothing changes. So as this part here goes to the top, I get 3a plus 3. And then as this one goes to the bottom, 9a plus 9 plus xa, and multiply 1 doesn't change it. So this is my answer for practice problem A. Once again, it's just a lot of the same stuff again and again. All right, once again, we just have a bunch of layers here. And so in this particular problem, we need to keep our z's from looking like 2's and our q's from looking like number 9's. I try to keep that straight there. But once again, we start at the smallest part here, and we have q plus 1z. We're going to get a common denominator because q's over 1 right now. So as z is going to be my common denominator, q does not have a z, therefore we're going to get one there, and then my other term on the top here doesn't change because the denominator is already there. If I bring my p into it, if I write the p as a fraction, it's going to look like that. And I want to combine these two fractions, one in the numerator, one in the denominator, to be one fraction. So I do that by inverting. Right? So everything cancels on the bottom, and then what I do on the bottom of the larger fraction, I also have to do on the top. So it looks like this. And as I multiply that out, I'll write that down here. P times z, there we go. And then 1 times this doesn't change that. I get my q, z plus 1. So I'll fit that back in. And I now have an x sitting out front here from there. And we're back kind of where we started, where that looks like that. And I've got two terms, two fractions. I want to get a common denominator to be able to add those. Once again, my common denominator is going to be q, z plus 1. So this one, I got to add it to the bottom to make my counter, so I also have to add it to the top. So that looks like x parentheses, because multiplication, right? QZ plus 1, and then plus, and then that part doesn't change because it's already got the whole denominator. All right, let's remove my parentheses and rewrite that. So I'm going to get x QZ plus x plus PZ on the top, and then my QZ plus 1 on the bottom. And then bringing back this here, I'm still inside of a larger fraction, which looks like m over 1. That's where this is tricky, just because it could layers upon layers upon layers. So once again, I want to be able to get this fraction in my denominator and this fraction in my numerator to all be in the numerator. So how do I do that? Well, I invert, right? So if I put my QZ plus 1 and then all this down here, everything cancels. And then same thing on the top. My QZ plus 1 goes on the top, and then this guy is going to go to the bottom, and then we're going to multiply it out. Parentheses here, because this m gets multiplied by both of those. I believe we can just leave it that way if we'd like to, though. M, ZQZ plus M. There's my top, and then 1 times what's here doesn't change that at all, so I'll write that out. X, Q, Z plus X plus PZ. And that there is my answer for practice problem B. If you have any questions, please feel free to contact me, and we'll work through that. Have a great day.